Hello, everybody.
Hello.
Hello. So let's wait 2 minutes before we start. But meanwhile, how are your projects going with the CapCut website? You have plenty of time, no worries, but just to know. And Chilio, do you want to say something?
So yesterday I did the coding session. So I just, the rest of the evening, I just spent like preparing my, like my colors and images and doing the prototyping on Figma. So I started coding today, just like mostly on the HTML and then starting some of the CSS. And I was trying to figure out how to like get the image to resize. But yeah, I've figured it out. But some other things to look into now. So.
No worries. When you finish the website, you will feel more comfortable with that.
Yeah.
So let me close the Slack so I don't hear the noises, the TQ and the TS, by the way, are available. And tomorrow they will be available actually during the entire afternoon. I will mention that tomorrow in the morning. So don't worry about that. Perfect. It's 5 o'clock. So let me start sharing the screen. Again, like the previous optional lecture, there is no PowerPoint slides. So let's get started. First of all, what is TypeScript? And most importantly, I hope that if at the end of this lecture, you decide to research a little bit more about this, because if you want to be a front-end developer and you want to start building large-scale applications, TypeScript will translate your Java skills into the front-end world quite nicely. But first, what is TypeScript and why it was invented? As you probably see during these days in JavaScript, JavaScript is an interpret language. What I mean by that is that you write some code in Visual Studio or any text editor, and then there is no compilation. You just save the file, and there you go. It's ready. You reload the web page, the browser, and then the browser starts running your code, no questions asked. For a beginner, that's an amazing thing. Why? Because we don't need to set up the compiler. Remember the very first day that we needed to install IntelliJ, we needed to install Java, and so on and so forth, and many plugins. Well, the entry barrier for JavaScript is just create a index HTML, and you don't even need to create a JavaScript file. Just inside the HTML, you can start writing the script, and it will work. So for a complete beginner that never coded in their life, getting started with JavaScript is super easy. The problem with with this approach of not having a compiler is that the compiler, even as annoying it is to set up, is a nice investment. Why? Because as we saw today, for example, many people were seeing that I was making a mistake. For example, I was calling a variable called UL instead of OL, and the IDE Visual Studio Code cannot tell me anything because there is no compilation. So I will never get the help from the software to detect this kind of silly mistakes. And to be honest, this is the kind of mistakes that are human kind of mistakes. It's not about a senior or a rookie person do more this kind of mistakes. No, this is human errors, and no matter how many years of experience you have, you will make these kind of errors. People are busy. You don't only have one job. You have multiple tasks that you need to complete in the day. You are super busy with stuff outside of work, so you will make typo mistakes all the freaking time. Like it's part of human nature. It's quite annoying that that there is not a compiler to help you from yourself. So people from Microsoft decide, you know what? We know that the web is the future, and I'm not joking. Everybody is moving to the cloud. You probably hear about that all the time. And the web is there to stay. JavaScript is here to stay, at least for the next 10 years. So people say, you know what, we understand and we can see the fit. JavaScript is the language of the future. Forget about Java, forget about C++, blah, 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 blah. The king of the languages right now is JavaScript, and that's what it is. But we have this problem with the interpreter that we don't have a compiler. So let's create something like that. So smart people in Microsoft, actually one Danish person decided to create a language that builds on top of JavaScript, and this language is TypeScript. So I know that we don't teach C# here, but C# and Java are quite close. So they are almost like brothers. They are super similar. So if you start researching on your own C#, you will see code that maybe the word string is on the right instead of on the left on Java, but you will be able to read C# code without any issues at all from your Java training. And if you see TypeScript, well, TypeScript is quite close to C#. Why? Because this is from the same creator of C#. And what TypeScript allows to do? Well, install a compiler for our projects, number one. So by having a compiler, each time that you save your files, they will be compiled onto normal JavaScript. And during this stage, the compiler will detect errors. We can see that right directly in the homepage, in the homepage of TypeScript, and the TypeScript is typescriptlanguage.org, because even if it was developed by Microsoft, it's open source. So don't be afraid to be vendor locked in by Microsoft. And this technology is so popular that you just need to write in Google TypeScript, and this will be the first result. But right away, we can see that we're creating an object or a hash map in your Java language. We're detecting an error in the IDE. We can see console log, and we're trying to access the property name in this user object. But you can see that directly is highlighting with the red the name, that the property name doesn't exist in the object user, and it says that the only properties that exist are first name, and it's a type string, last name, that is also a string, and a role that is also a string. So you can start seeing that we get a compiler back again, like the compiler that you have in Java, and this will save a lot of time. And now that you can have a compiler, TypeScript will allow you to do stuff that JavaScript was never designed to do. So for example, just a couple of years ago, JavaScript added the feature of classes, but the classes in JavaScript are super weak. So for example, you can get getters and setters in the JavaScript classes, yes, but you cannot do inheritance. So remember the exercise that Kevin and Johan were teaching you about creating the animal class and then extending the animal class by creating the dog class, and the dog class can have a specific property that only the dogs can do, like digging in the ground, or create the cat class extending from an animal, and then you can have properties that only the cats can have, like for example having more than one life or being evil. So you cannot do in normal JavaScript that, but in TypeScript you can do it. And the cool part is that because TypeScript is compiled to normal JavaScript, you can use all this in an older browser. Well, not that old, but maybe 5-7 years ago, because it will be compiled down to normal JavaScript. The browser will never know that you were using TypeScript. So number one, we have powerful classes that allows us to do encapsulation, polymorphism, inheritance, and so on and so forth. Feature number one, powerful classes. Feature number two, allow us to have scopes, much better scoping than pure JavaScript. So we can create classes with private, public visibility, just like you learn in programming foundations. That will be another one. It allows us to do a strong typing. What do I mean by strong typing is that we can actually define that one variable is the type string, and we can say that once it's declared as a string, we cannot change the data type for a number or an object or an array, something that in JavaScript is quite, you can do whatever you want. So to the point that once you want to do once you want to do serious application, this liberty that JavaScript gives you that were amazing for a beginner when is learning becomes a double-edged sword in a professional environment, because they can introduce bugs that are virtually impossible to test. So so it will be super difficult to do that. So that's another advantage. Allows you to create interfaces, just again like in Java. Basically, it will have feature parity with C#. C# is basically the same thing as Java. So you will have feature parity with Java, to the point that all your skills in Java can be translated here to TypeScript. To the point that if you did a good IP project, with the last exception of the creating the file into the hard drive, that JavaScript will not allow you to do that because you're inside a browser. Well, all your classes can be ported to TypeScript without any issues. And that class that stores, by the way, I really hope that you have a separate class just to read and save to the hard drive. You just modify that particular class or create a copy, and instead of using text files, you just save to the local storage or to a server, and there you go. You will be able to port your super advanced IP project. And remember, the print command in Java is the console log in JavaScript, so you can literally convert your entire application without any issues. Something that will be impossible to do in JavaScript, because you will not, the classes will not behave as you expected. You will not be able to do polymorphism. Even if polymorphism means that you can convert one data type for another, JavaScript just allows you to modify any kind of variable. But the polymorphism is that allows you to specify the set of rules. Okay, this variable can receive elements belonging into this particular class that extend for this particular class. So you set the rule that how much you want to extend a class in Java, a variable in Java, allow a variable to have, but in JavaScript, everything can be everything at the same time. So it's super dangerous. So again, TypeScript is super useful. So, okay, before I start showing a small example of how to install it, I want to take the time to showcase an example of a large scale application. This is the example that we're going to build, by the way. Yeah, but let me open the SDA platform at all, so we can see professional Java TypeScript in action. So let me open the documents, the tab, the SDA LS. Oh, by the way, you can make questions all the time, remember. So let me open the project. I know that we haven't covered React yet, and don't worry, we are not gonna open any piece of code of React yet. But okay, this is the project folder of our dear SDA platform, the same platform that you use all the time. So as you can see, we have one folder just for pages. We have one folder for interfaces. So you can see this, by the way, the extension for TypeScript is TS, and you can see this blue icon with the TS. You can see an interface where I'm defining for example, for your login credentials, when you want to log in the platform, when we create an account, you need to pass the value name, email, a new password, and the activation code from the SDA. Remember that we always mentioned during the software engineering, and I think a couple of days ago as well, the old platform was coded with pure React in the front end. Well, multiple technologies in the back end that were amazing, but in the front end was pure React without TypeScript. Because of that, there was a bug that if you put the activation code wrong, or you totally forgot to add the activation code at all, the front end will send the data to the backend, and because the backend will proceed to create an account, but when you reach the activation code, the validation of the activation code, it will throw an error that, hey, this activation code is invalid because it's null or empty, but the account was created. But the front end never catch this mistake. But because we literally have an interface called authentication, if from my SDA platform. Let me open this one. From the front end, from React. I don't need to show React right away, don't worry. I will not show any code of React, but let's create an account. But if for some reason, I, as a developer, as a React developer, I forgot to add this field, but I'm working with developers that are following TypeScript, we can agree to work with this interface authentication. And the moment that TypeScript catches that, hey, you're only sending me 3 parameters, you're not sending me the code, it will catch this error during compilation time. So I don't need to even run the code in the browser to detect this kind of errors. This is fantastic from our side. Let me see if I can show you something. Try to show something without touching React, because that will be for the next week. If not, and then I will show only the TypeScript code. But let me see where this file is used. So we go to page, we go to create an account, and this is where is sign up. Sign up as a model TS, and this one is calling this file authentication. And then here is where we catch any mistake. This is the create account function. I will open. Unfortunately, I need to open the React a bit. Don't be scared about this, please. In any case, I create an account. I'm sending the name, the password, the name, the email, the password. But if I delete this one and only pass this one, and I try to compile the code during compilation, this will throw an error and tell me that the object that I received do not work because it's missing the code that is a type string. So during compilation, it will detect this error, and this is super important for us as a developer, because when you have a big project with a lot of lines of code, these kind of mistakes are super easy to do. So that's why it's super important to have this one. And also, to make your code more robust, you can also tell the machine that your function has a return type, something that we do in Java, but we don't do in JavaScript, because in JavaScript our functions can return data, but we cannot enforce that the return type is a certain type. And I think that I can do this one in particularly even before open the compiler, without even compiling the code. So for example, I say, instead of returning user data, I will return SDA demo. And the compiler is showing me that it cannot find SDA demo. So I will create a variable SDA demo, const SDA demo, and is equal, for example, equal to 0. And it should, and during compilation, this one will fail. Not right now, but during compilation will fail, because the return type is a promise, and the promise can be any kind. For example, if I just change it to a string, this probably also will fail a little bit better. There you go. This one will fail because it's saying that it's a string, and number is not assignable to type string, and I think it is a string with lowercase. Just give me 1 second. There you go. So it's not assignable to the type string. So as you can see, TypeScript allows you to detect a lot of errors even before you hit the compiler. As soon as even if you don't need to press play, it will detect a lot of errors. And the error that it was allowed to pass the number, even if the Visual Studio Code didn't catch it, the compiler, the TypeScript compiler, will catch it. Because trust me, I already, the compiler has saved me multiple times when we were developing the SDA platform. So that's an advantage for that.
Yeah, Eduardo, if you want, I have a project set up with the live server and everything, which isn't React.
Yeah, I also have a project, by the way, no worries. I build.
Oh, okay.
Yeah, of course, no worries.
No,
yeah,
no, I was just saying because you didn't want to show it in React, so I was saying you can just run that and I'll run. Okay.
Exactly. No. I do have a smaller demo, the classical dog and animal and cat, blah blah blah. But I wanted to showcase an example of real production code. Like, okay, this is how you will actually use React in real life, because I will build a small demo right now, but the problem with the small demo is that the small demo will showcase, oh, I can make strings, I can make numbers, but I really wanted to showcase, okay, this is how you use it in a real environment. So, okay, without further ado, let's create a small example for, yeah, go ahead.
Eduardo, actually, I have a question. The example which you have shown has a file name like I authentication, and some other files also have noticed like E something .ts. Why is the difference? I stands for interface, and what is it E?
Oh, good question. And what a nice eye. Let me open the project again. I love this kind of question. Thank you so much. Don't worry. I will open the project again. LESSN, yes. Okay, so many of them has an I. The I is for interface. For example, we have the courses. The courses always needs to have an log date, blah, 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 blah. And this one, for example, you can see that it has a e-course type. And this is important e-course type. So let's open this e-course type to see what it is. So you can see document, slide, video. Let's showcase in the real platform what is this about. So I will log in as a student. No, I will not change to change my password. So we have in the SDA platform a course that have content classified by documents, by slides, by videos, by coding repositories, evaluation projects, and so on and so forth. And if I log out, remember that the user side and the admin side are totally different. If I log in as an admin, I have the screen to module contents from development, and I can add the content, and the content can be, for example, for certain type. For example, it can be a document, it can be a slide, it can be a video. But imagine that another federal developer made a mistake and add a new type that doesn't exist. I don't know. It makes a typo and he says documents plural. I know the title says document here, but in the code base it's called document singular. Imagine that somebody tries to pass an element in the database with a plural. TypeScript will catch it because this enumerator means that this type is this type is a string, but this string can only be these 1, 2, 3, 4, 5, 6 elements. So if I try to pass in the database, I try to pass another value, and let me literally open the database. This is why it's so important to showcase real examples, because this is why it's actually useful. Let's see, where is my Firebase project? So for example, here, I log in with another account. Just give me 1 second to log in with my SDA credentials. SDA project, there you go. This is the credentials of the SDA. This is our database. Let me open the courses. Let me see front-end development. Let me open the content. Let me see this file, for example. And this file is typed document. And as you can see in the database, and this happens regardless of if you are using Firebase, MySQL. Imagine, and remember that we're working as a team, so I am not the only one with this particular credential. If somebody opens the database here and just puts a small s, it will break the entire, it can break the project and will not be able to catch where the problem is. But because we have an enumerator, the enumerator will, as soon as it catches that, as soon as it detects that there is a string called documents with S, the error will not be in normal JavaScript. It will be something like undefined, and there is no information. With TypeScript, without opening the browser at compile time, it will say the document, the file ABC has a key type with that doesn't belong to the e-course type, only e-course type. There you go. I need to correct this one. But it will catch that you don't have the correct e-course type. So it will say exactly where is the mistake. And it will say, In this case, it will return. I will put the string in the database. Documents says documents doesn't match the available keywords that are document, singular, slide, video, and so on and so forth. So enumerator allows me to say this particular string, this field is type string, but the only values that I'm allowed to use in this particular string are the ones that are defined here. And where I also use this one is in the icons. We can only use these icons here because we have imported the icons from Awesome, the library that I will show you. So I cannot add an icon that doesn't exist in the from Awesome library because we also have the same protection, and so on and so forth. So yes, that is the enumerator for, and we can actually go directly TypeScript enumerator. And this is a web page, official documentation. So as you can see, you can start adding keywords, and doesn't only work for strings, it can work with other data types as well. So yeah, that's the enumerator. Any other question before we move to the small example?
Thank you, Adrian.
No, but don't worry, this is the kind of questions, and this is why it's so important to have a TypeScript. And as you can see in the SDA platform, we took our time to create a lot of type interfaces to be aware that this is the kind of stuff that we need to be aware of. So, and this allows us to work as a multiple developers in a single team without being afraid of making mistakes. Because if we make a mistake, and as I told you at the very beginning, before everybody logged in, making mistakes is normal. The problem is that we don't have any, the important thing is to have protection against human mistakes, and TypeScript will allow us to do that. So, okay, let me delete let me close the SDA platform example. Let me open the example that I made. I will show you just very quickly before we actually code it from scratch. So example, this is the project. And this is the project that we are building. This is the important part. This is our project structure. Usually in TypeScript is not designed to work, well, it can work on small examples, but it's designed for more bigger projects. And bigger projects, just like the one that you did with the IP project, you don't put your files directly in the root of the Git repository. You have one file called source just for your particular files. And in this source directory, I have my index. My index is only calling one file, and this is important. Somebody made a question in the morning that, can we import a single file? And I told them, we need to learn about modules. Hey, there you go. These are the famous modules. This time, this will be real important, like the one that we do in Java. So for example, in this case, my file, and you can see that I started to use uppercase names because these files represent real classes. And these classes are importing files. So this class, for example, main has a constructor. We are not faking the constructor anymore like we did in JavaScript, that we create a function called start or init. Now we have a real constructor for a real class called main, and we can create a variable name that is a new instance of main, and we can pass the initial arguments. So that's one. And this is my folder with my source files. This will be the equivalent of your .java files. And thanks to this configuration file called TypeScript config.json, I know there is a lot of files, but don't worry, this file is created by default. And you can copy from project to project. This one just tell the machine, okay, where is my source folder? Where is my project file? Where is my project start? My project starts at source. And where is the output? Where do I want to put my compile files? Because these are the files that the browser understands. Remember, the browser doesn't understand TypeScript at all. The browser understands JavaScript. So each time that you run the compiler, it will create one file, one mirror file for each of these files in the respective JavaScript equivalent. So for example, if we open, for example, animal TS, and this is the cool part, I can open animal TS and I will zoom it out. And you can see that it's quite close to your Java. I think that you can understand this file. you have your export default means that this is that we have only one class per file, because you can have multiple classes per file, but it's a bad practice. So I always get used to have a single class per file. In this case, we say export default class animal, and then we have our variable name, and you can see that we can assign the data type. And if we change the data type to, for example, number, we can start to see errors even before we compile. In this case, it says type string is not assignable to the type number. So the Visual Studio Code can understand TypeScript even before we compile, just like IntelliJ IDEA do something similar. So, okay, let's move back to string. And then, for example, here, I can pass, for example, I can do something different. I can pass, for example, true. And then we will try another compilation error. I pass the mouse. It says type Boolean is not assignable to the type string. So you can see that without even running the compiler, Visual Studio Code is smart enough to start understanding TypeScript and understand that in TypeScript you need to respect your data types. So let's continue analyzing this example. So we are creating this. We're going to create this exercise. It's quite basic, I know, but let's go ahead anyways. Just give me 1 second until it loads. So yeah, this is a typical object-oriented, the object-oriented example that everybody uses when you start to learn coding. So we have animal.ts. It's blue because TypeScript is blue. And this one can, and doc.ts stands from animal, and cat also stands from animal, from cat, ts. They also stand from animal. And animal will have the properties, will have the normal properties, will have the property name. And now, thanks to TypeScript, we can start writing more efficient code. In fact, I can, because TypeScript is a more so robust language than JavaScript, I should even starting to use class diagrams, because now I can start specifying if my variable is a data type, or is this public or private. So I can even switch from this whimsical application to what was the tool that we were using? Lucidchart. To Lucidchart and start making real class diagrams, because now we can start specifying information that doesn't exist in JavaScript at all, like type and visibility. So we can do our encapsulation. So in this case, we're gonna say private name is a string, and a private sound is also a string. We can do more complex examples with enumerators, but I just want to give the basics, and then you will go on and build more stuff, complex stuff. And I can just put this one second. I will put this one on top just to make it the element. And this one will extend, the dog and cat will extend from this one. And you know that I don't need to say pass name and sound, because you know to read a class diagram, and you know that the dog and cat inherit name and sound. But dog on his turn will have a new property that only the dogs can have, that is dig speed. That's how fast they can make holes in the ground. So private, and it will be private. And this will also be, for example, it will be a number, because it's a value from 0 to infinite. And the cat will have different properties as well. It will have, in addition to name and sound, yes, let me get this one a little bit larger. So yeah, so we can have everything in a single line. So this one will have, for example, private is evil, and this is a Boolean. And of course, we can have default values, so we can say that by default is true. So this is the thing that we're gonna build. And let's see how this particular example that is And a TS file will translate to the equivalent in JavaScript, so we can analyze the code side by side. I will make it a little bit smaller so we can see it better. So animal GS and animal TS. So we can see that directly we cannot declare variables outside the constructor. They are directly in this name, this value, and this num, and they have the getters and setters. So far, so good. But you can see that we are losing the capacity to determine to set the data type. We lose our accessors to enforce that are private. Something that we can say with the public. In this one, everything just you get the getters, but you cannot specify that it is a function or a property is private or public. So everything is accessible. So yeah, that's bad. And now let's see how the inheritance works. So for example, let's open the doc example here. Let me close animal. Let me close everything, only the doc and the equivalent doc. So let's see. It has an extension, but we lose all the amazing properties of the string and the sound. We don't have interfaces, we don't have enumerators, and so on and so forth. So we lose a lot of valuable information when we start working with the classes. Well, okay, now it has extend. At the beginning, a couple of years ago, JavaScript classes didn't have the extension, but you lose the interfaces and the enumerators and so on and so forth. So that makes JavaScript quite dangerous to work on. And we cannot define the methods as private or public. So, okay, let's build this small example, shall we? To install TypeScript for a new project, just let me delete everything. Go to the desktop and delete. We're gonna build this. So let's go here, and we can see that we need to install this command. So we do we open the project. We have the one that is created. We're gonna create a optional live TypeScript. So we're gonna open this one. Perfect. Let's say that we're installing TypeScript for the very first time. So we copy this one. There you go. It creates a node package. That means that you need to install Node.js because the reason that we can compile TypeScript is because we're installing a virtual server that runs JavaScript behind the scenes, and that server is the Node.js system. And on top of that is running our TypeScript compiler. So okay, and I think that to create the TAS config is create a TAS config. We install TypeScript backend. Cool. Let me see how do we do it. So we can check. We can say TSS init. Okay, no, we need to install the command. First, okay, let me install it again. TypeScript. If you need access, you need to do the sudo. Perfect. Now let's check if we can do the TSC version. Perfect. Now we have a TypeScript installed. Now we can say TSC init. Perfect, and it creates a configuration file. Perfect. This one has a lot of options. You can see that everything is commented. You will need to take a little bit of time to read everything, but that's why I had one from the SDA project. But let's see, the most important one is the target. You can decide if you want to compile to EX6. We have this version. This is the most important ones. We have EX6, ES5, that is the old JavaScript, and there is even older versions. We have this one that is called, this one is EX6, that is the modern standard. And then these ones are supersets. Like this one has a new feature here, a new JavaScript feature here, and so on and so forth. EX next means I want to convert my TypeScript code into the most modern version of JavaScript. So even if we're in the year 2025, we don't need to go back to our project and say I move this code from ES20 and the next year to change it to 21, then to the next year to the 22 and the 3. No, you just say EX next, and you always, each time that you compile the code, it will check what is the latest version of JavaScript and compile them to that. But in any case, I want to use the same project, the same configuration file that I have in my SDA platform code. So this one is just everything, but with everything that I don't use deleted, and I want to compile for modern browsers. It is not the latest version, but it's not all. But it's also not the oldest one that will make our code work, but it will make our code slower because it needs to start to add a lot of code, boilerplate code, to try to simulate features that didn't exist beforehand. So for example, let's use an example of the classes. Without extensions, you will need to copy the value of the other class and copy the parameters from one file to another. So yeah, it's super annoying to do that, and that will lose performance. So instead of cutting edge, I choose something in the middle that is a JavaScript 2015, if I recall correctly. I think that somebody was trying to say something.
Oh, yeah, I just unmuted myself. I was wondering what's boilerplate code.
Oh, okay. Oh, I'm so sorry for speaking jargon that you didn't know about. So, and each time that you hear something, that I'm saying something like with all the confidence in the planet that everybody knows, boilerplate code means, let me show you the best example was, let me see, Control C. Let's see, Control C. This is boilerplate code. When your code has a template with all the possible configuration files in the world, just in case, and we don't want that. We just want to focus on the stuff that we need to use. So we say boilerplate as all the necessary files, the needed files, the lines of code that we need something just to run, but that we don't need it at all. So that's what I was referring. So sorry for that one.
Thanks.
No, but don't worry. And in fact, I deleted a couple of lines of code here. That, for example, one of these one was referring to GSX. That is something about React. So that was even more lines of code that I don't need for this particular project. So that's why. And I can even reduce a lot of these lines of code, but to be honest, I don't remember which ones will break the project. So unfortunately, we can say now that this file has a lot of boilerplate code because these particular lines of code are designed for the SDA platform. I can start removing a couple of lines of code, but right now I don't know which ones are the real ones that I need to keep in order that the project to work. So unfortunately, just to be safe, I have everything there. I just delete one from React that says JSX. So we know that we have a lot of boilerplate that we don't need, but are there just in case. In any case, okay, we have this configuration, and this configuration says that we are gonna put our files in the source folder. So, okay, this will be our entry point now, source. And this says that every file that we find in our source folder, every single TypeScript file that we find inside this folder, and it will check it out in nested folders as well, will be outputted to the JavaScript folder. So, okay, we don't need to create this folder because it will create it for us. So we're gonna create a folder called new folder TS. TS stands for TypeScript. And inside TypeScript, I will create a new file, and it will be called main.ts. Main.ts, perfect. And now we can say export default class main. We have a constructor. And in the constructor, we say, for example, we're just gonna have a small debug we're gonna debug string, just to pass a string, just to test it. There you go. And inside here, we're gonna put the value, for example, private, because we can be, now we can say that it's public or private. Private debug. If you ask why are we using underscores, this is a convention from older languages where variables or properties, let's use the object-oriented terminology, properties that that doesn't have an underscore means that they are public. So just by a quick lookup, string, sorry. So by checking this, so for example, I will say public hello, string as well. And imagine that you are around here right now. You know clearly that this one is public and this one is private because we can see the name here. That will make no sense to say, oh, we need something special. But imagine that your project is long, like really long. When you're around here, to access these variables, you need to say this debug equals I don't know by. There you go. And this hello equal blah blah blah. Right now, here, without passing the mouse over the properties, we don't know if they are private or public. But because we are using this convention of the underscore, underscore. Okay, this one is private, and this one doesn't have an underscore. This is supposed to be public. So this is why I'm using this. Let me just control save. I will delete all my junk. Perfect. So this underscore allows me to understand that my property is private. And the same things we can do with the methods and the methods and the methods and properties. Yes. So okay, let's define this value, and let me make it. I will delete this one because I don't need it. I will say this debug underscore equals debug, and this is the value that we're going to create. And let's do a console a constant. Let's run this code. Main equal a new instance of main, and it's telling me that which data type I need to pass. Cool. Now I get a string. So if I pass a number, I can pass my mouse. It says argument of type number is not assignable to the parameter type string. Perfect. So TypeScript can tell us this kind of stuff. So we're gonna say just foobar. Foobar, by the way, you see this one in Stack Overflow. Foobar is literally a generic variable name when people don't know what to code. Just foobar is the normal name. And then let's do console log. Console log. This is working, comma. This debug. There you go. And now let's run this code. We go to the terminal and we say TSC. I think it's W for watch. Let me see if it's starting compilation in watch mode. Perfect. And cross our fingers. And there you go. We have the folder that we created, and now we have a new folder called GS. And inside GS, we have our file. And now let's see here. This is the file that we're going to run. So let's go to the index. Oh, we don't have an index. Let's create an index, new file, index.html. Let's create, again, boilerplate code. This is a template. Boilerplate code, I don't need this. I don't need this because we are not going to use the special characters. I don't need this because we're not going to make a responsive site. I don't need this because I don't care about the language right now. I don't need this because we know there is an HTML5 and we're going to use a mother browser. I don't care to test this example in an older computer. We don't need this as well. And you know what? I don't need this. So yeah, you can see that how many lines of code are not necessary, to be honest, in this particular example. But in any case, we're going to say h1 TypeScript optional lecture. We need this so we know that the code is not, there's something on the screen. And they're gonna say script, and we need to be a type module, and they wanna say source, dot slash. And remember, we are not gonna run our TSS file. In fact, we cannot do it because the browser will not understand it. We open gs/main.js, and there you go. And I will open this one. I will open normally with the Finder, and I think, I will open this one with the Finder, opening Finder. I will open this, and I'm pretty sure that this one will fail on purpose. But let's see the console log. I will inspect the element. I go to console log, I will reload, and you will get this error. This is super cryptic, by the way. Origin null is not allowed by access control allowed origin. And again, the same message as access control allowed origin. Type error cross origin script load denied by cross origin, blah, blah, blah. If you don't know what is this, the problem with the modules, and this is a security feature. To be honest, I don't know. I don't know why you can import older JavaScript files, and the normal JavaScript files can contain dangerous code that can hack your computer. But because that's a security risk, when we went from normal JavaScript files to modules, that is the new modern way to import files, the people from the standards in JavaScript says, you know what? It's super dangerous to load JavaScript files from the local computer. Imagine that somebody sends you a JavaScript file from an email attachment, and then you it sends you an index HTML page or a web page X, HTML file and a JavaScript file, and you open the web page, and boom, you have a virus installed. So when they create the modules, they say, you know what, this is super dangerous, so we are not going to allow to load modules from the local computer for security reasons, just like that. Unfortunately, they forgot that the older JavaScript files that can contain virus as well will work without any issues. So modern JavaScript for security reasons don't work from the local computer, but older JavaScript files that can be as dangerous or even more dangerous than the newer files can work without any issues. That's why I didn't want it to, in the morning, to use modules, because I need to explain this kind of information. But we're going to see that in React, don't worry. In React will be mandatory. So, okay, how do we solve this? We know that we cannot run this code from the local computer. We need to put it in the server. We can create a Firebase project, but that will take so much time. So for now, we're going to literally create a hack, and the hack will be open with live server. This will create a virtual server on our computer, and our Safari browser will never know that we are running code from a fake server instead of a real server. So let's do that. There you go, and now it's working. Because as you can see, we are running from an external resource. We are running from a local computer, a local server, a virtual server in this address. And if we go back to the one that is in the local computer, you can see file::colors users Eduardo desktop. This doesn't work because of the security reasons. It's a little bit stupid that you can run older files that are even more dangerous, but you cannot open the new ones because of security reasons, but it is what it is. But in any case, it's working. Let's create the inheritance example. And if we have time, we try to reach the interface and the enumerators as well. So, okay, we're not going to put anything on the screen. We all just want to run with console logs, Java style, so we can see the perfect analogy. So I will close this index. We're going to close this, and this is the important part. Remember, if I do this, compilation error. No, let me actually compile it. There you go. I save, and you can see the X. We have an error. Now we have a compiler. Now a compiler just like Java. So we say argument of type number is not assignable to the parameter, the type string. So, and even I can close these files, and Oh, sorry, I closed the incorrect file. So anyways, I can double click here and it will directly mouse, put the cursor where the error is done. So let's fix this by saying hello. There you go. Now we don't have any problems. Zero problems in watching files. But remember, if we do this here and changing from here in the JavaScript, it passes. Imagine that you are trying to save one value in the database. TypeScript will protect you from that. JavaScript, no. JavaScript will allow you to put any value. Remember the example that we were talking about, the numerator, that you only are allowed to create a file in the SDA platform, like it's either a document, a video, a slide, and so on and so forth. Well, this one will allow me to do pass any value, and that will be a mistake. So as you can see in JavaScript, nothing happens. JavaScript allows us to do anything. But in TypeScript, we can define that this value is a type of string. So that's why, and this is the important part, I will delete this one. Never modify your JavaScript files. So let me see hello to, just to, so I can create again. So never modify your JavaScript files, the compile files, because if you make a small change here, you will lose all the superpowers that the compiler gave you. So if you put the value here, nobody will detect the error. And then when you try to save something in the database, all the protection that you make here on TypeScript will be long gone. So basically, never touch this folder. You import this folder, is right. You're importing the GS, because if I put TS, so for example, if I go to TS and I reload the page, optional lecture, blah blah blah. It went crazy. I don't know what is this type file type. It's not a valid JavaScript file, because the browsers don't understand TypeScript. So I need to put a JavaScript file. It's okay. This is basic, and now let's build a little bit more complex. We can create folders inside folders if we want to organize our project. Remember that David in IP was telling you create the packages. We don't have the word packages here. We use folders, so you can create something like that. But for this small example, I will just put everything here, and we're going to create the animal class. Typical example, I know, but my goal right now is just to showcase how close to Java is this. TS. Again, export default. And if I don't put export default, by the way, I just can do directly class animal and blah 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 and constructor blah blah blah. There you go. And let me see what is the error that it says. Animal cannot be compiled because it's considered a global script file. Okay. I need to say export class. Okay, thank you. You can see that the compiler helps. I can have a export here and export class. I don't know, plain. But it's a bad practice. Don't do that. One class per file. So to tell that this is the only file that we're going to have, default. And I think that we can also use a final or abstract and static and a lot of keywords from Java and so forth without any issues. So okay, let's say that let's go back to our whimsical example. We say that our animal has the default properties name. We're gonna say a name to the animal. We're gonna say the sound that it makes. So let's say private underscore name type string. And I don't even need to say string. I can just go directly empty string. And the compiler will say, oh, this is a type of string. That's called inference, that I can the code is intelligent enough that, oh, you passed me a string, so it must be a string. But because if we are going to switch from a disorganized language to like JavaScript to an organized language like TypeScript, let's use the features that are give us and always get used to write the data type. So it's a type of string. And we're going to create another one called a sound to know the sound that it emits. Again, there you go. And in the constructor, we're going to say name, for example, number. I'm making a mistake on purpose. Sound is also, this is a string, perfect. And then I will say this underscore name equal name, and we find an error. Number is not assignable to the type string. Perfect. So I need to change my signature, my data type. Perfect. And this sound the same, equal sound. Perfect. We want to, because these ones are encapsulated, we cannot access them. So let's test it out, that one. So we are gonna import the file. In this case is import animal from. This is important. I in the SEA platform, I actually have set up the tsconfig.json to just so I can open the TS file, and then the machine is smart enough to actually know that it needs to replace to the other data file. But to be honest, due to time, I didn't have time to complete the exercise. I think in this example I will open the animal.js. But you can config this to actually work with the real TS file. Just let me confirm, by the way, just give me 1 second. If I am doing that in the example that I created a couple of seconds ago, the one that is a optional TypeScript, let me see my open file and say open main TS, open with Visual Studio Code. Yeah, I'm making I open in this file from this one. So I just can say, sorry, in main./animal.js. So I will import the JS file, but I know that I need to import the TypeScript, and there is a configuration JSON that you can modify for that one, and you can research it later. When we reach React, I will probably showcase how to do how do I set up the project over there. In any case, now that we have this, we can create a constant animal equal a new animal, and we have some name, because this is an abstract element, and some ick, because we don't have developed this prototype animal has not developed vocal cords yet. So console log animal, and if I press dot, I don't see anything. I cannot press dot because TypeScript protects me, and these ones are totally encapsulated. So if I want to access the properties, I need to go to a getter, get name, and return this name. Same with get sound, return this sound. And if I go, and remember, each time that I save, it compiles. And if I go back to my main file and I delete this one, I go again, console log animal, and if I press dot, now I have the properties. Property animal.name, and it also says that the data type and sound, if I move the mouse, is also a string. So we get a lot of information from the compiler thanks to that. So let's log this one. Some name, perfect. So let's extend this example. Now let's create an extension. So new file, .ts. I will go a little bit faster this time. Export default class and doc extends animal. And as soon as I do that, it will extend animal. I need to put the GS. That's because I didn't set up my config correctly today due to time. Sorry for that. And then I will gonna add new properties that only the dog has that no other animal has. So for example, I would say the dig speed, dig speed, type number, default value 0. Oh, sorry, I use normal JavaScript. Private, and another mistake, underscore. So sorry, that was pure JavaScript. So now we are in a different language. Now we are in TypeScript. So constructor, and I say dig speed, type number, and then this dot dig speed equal dig speed. But it's throwing an error. Let's see what is the error. Let's hover over the mouse. So it says constructors derived from other classes. In this case, for the extension, needs to call the super class. So, okay, I call the super, no problem. Super, perfect. We have a lesser error. It now doesn't, the entire constructor is not broken. It's now super is broken. It says, and problem, expected 2 arguments, but got 0. The argument for name was not provided. Oh, okay. Now TypeScript is helping me. If I try to call this dog class, because dog extends animal, we need to pass also the name and what was the other property? Sound. We need to pass sound and sound and name. So as you can see, TypeScript is protecting my for myself. So let's do that. Name, number, sound, string, and let's pass the data. Don't worry. So name and sound. There you go.
I think name was string, I think.
Yeah, nice. And TypeScript also catch it. So yeah, argument design is type number is not assignable to the type string. So thank you, Cory. And remember that I had this. I was making the same kind of mistakes when we were coding the to-do list in the morning. In that one, I really needed that that somebody else told me that, hey, you are using the correct variable name, because JavaScript didn't get it, but TypeScript gets it. So, okay, let's fix this error. We know that this one is type string. There you go, it's fixed. So as you can see, even in this small example, you can see how useful is TypeScript in comparison to
JavaScript.
Yeah, somebody say something?
Yeah, in comparing to the JavaScript, TypeScript is helping us more.
Oh yeah, a lot. Yeah. In fact, the SDA platform, when I was allowed to restart the project, number one, they told me you can use the technology, whatever technology you want. I was remember that I was telling this to the people in the graduation time of the SDA 8, and they told me, oh, because we have an optional lecture that we're going to have this next week when we speak about all the technologies. And I told them straight away, my favorite front-end framework is Vue. So I remember one of the best students was telling me, oh, so you will be able to make the website in Vue. And I told him, oh, by the way, somebody said I say too strong words. I use full language. So I will, if that person is here, I don't know the name, don't worry. I promise that I didn't check the name. So if that person is here, please cover the ears because I'm gonna say something important. It was a good student. We were actually kind of friends, and he tells me, fuck no, I will not make the website in Vue. Why not? Simple. Because I want to use the SDA platform as an example for the students next week in React. When we reach React, I don't want to waste the opportunity teaching React and the SDA platform is in Vue. No, next week will be fucking amazing. Sorry, then. that was not on purpose. That was by mistake. But I really looking forward for the next week because now I will be able to showcase every single trick that we do in the SDA platform that is in React. And if I did the platform in Vue, I will not be able to do that. So I tell him, no, I will not do the platform in Vue. In any case, even when I decide I will do it in React, so I can use this as a study material for the student next week, I have 2 options. I can use React pure, I mean React with JavaScript or React with TypeScript. I have a video for you guys that in case that you want to integrate React with TypeScript, but we are not going to do that in the SDA. Why? Because unfortunately that's a little bit more complicated, and that means that TypeScript needs to become mandatory instead of optional, because React is complex, and if you add more complexity, because remember now we are adding this information, the compiler, and so on and so forth, that will make React more difficult to learn. So I split the SDA platform in 2 parts, the front end in 2 parts. The React code is pure JavaScript, so I can teach you how all the little tricks about that. But the part that is connecting to the server, that part is done in, oh, let me open the diagram again. I love to do diagrams. I'm so sorry for that. Let's call this SDA platform. So let's say code that the users see. and I will put another box, and this is React plus JavaScript. This is the code that you see on the web page, and literally, let me put an icon, a laptop. Literally, this is what you see on the screen, is JavaScript with React. And I will use a different color. Remember, this is an optional. You can drop up in any second, and I don't care. I don't mind. Sorry, I don't mind. Sounds harsh. I don't care. But I don't care because I will not resent that somebody drops right now. But in any case, the code that connects to the database, this one is TypeScript. And I will change this color for this one's to, sorry, lighter color so we can see the difference. There you go. And this is a different level of hierarchy. So I will use different colors. There you go. There you go. And there you go. Yeah, I have mental problems. I need to make every single color perfect. And a server. Yeah, you know that this is the universal icon for a database. So yeah, this is the SDA platform from the front end side. And the backend, by the way, is Firebase. That's another optional lecture if you're interested. So I can show you next week about all the wonderful world of React. I decided to make this part of the platform React with pure JavaScript. But database management is super complicated, and one single bug can crash the entire application. Imagine that somebody, I show you in the platform, somebody just modifies one single value in the server or try to store a value that is not valid, it will crash the entire application. So this part, I call the shots and say, you know what, this part is super delicate. This part can be broken so easily. So unfortunately, unfortunately, I need to make this one in TypeScript for security. In an ideal world, I will make everything in TypeScript. This will be React plus TypeScript. But if I switch this part to TypeScript here, then the code base will look so different to the code that we teach in the mornings in pure React, pure JavaScript React, that you will not be able to understand the code base from the SDA platform. So this is a nice compromise between, okay, this is something that the SDA students can understand with, hey, I really need security before I touch the database, or if we get information from the database, I really need to curate it and validate that is correct. So that's why I have TypeScript here. So it's a nice compromise. So that's why I'm using TypeScript here. In any case, let's continue. To be honest, I don't even remember what I was speaking about this. I remember I was telling you that somebody asked me if I can do it in Vue, but I don't remember why I this diagram. Sorry. In any case, we create the dict speed, and we're gonna copy this one because for time constraints, and we're gonna create a cat.ts. We're gonna copy paste. We're gonna change this one to cat. It also stands for animal. Cats cannot dig. So we're gonna say, but they have a special property. They have a live. There are no type number, starting 0, perfect. And now we can see that the name doesn't exist. And another property, let's try a boolean, is evil. Boolean equals false by default, but we know that it's not true. So instead of the dict speed, we're gonna say live number, and we can set a default value, for example. So if the user doesn't pass an argument, it will have, I think it's 9 lives. And because, let's be honest, boolean equal true by default. So all of cats will be evil by default unless we state otherwise. And now we're gonna say this lives equal live. Of course, we don't have lives here. Oh no, yes, we are passing it. And this is evil equal is evil. There you go. So now let's go back to main.js, and instead of calling the, and we also can create the final. You know, we can create a final, so we cannot extend. I think it's in abstract the keyword here in TypeScript. If it's an abstract class, let me try to do that. If it's an abstract class, Sport abstract. No, abstract class. Abstract. Yeah, let me go here. There you go. Cannot create an instance of an abstract class. So another feature that JavaScript, normal JavaScript doesn't have. We can tell that this animal, we cannot create an instance of an animal because animal is a concept. There is no an animal. It's a concept that we as a human classify the animals. We have invented a word, and we have detected that the difference between a plant and an animal has certain properties that define that which one is an animal and which one is a plant. So we classify stuff. But we can create an instance of a cat, and we can create an instance of a dog. So let's do that. So let's create, instead of an animal, let's create, forget about this console log. Just go directly, constant. Inside this one is constant, it's okay. Constant cat1 equal new cat, source cat, perfect, we find it. I need to put the GS, remember, because my setup is wrong, sorry for that one. And cat needs a name, let's call it Whiskers. Sound, meow. Lives, let's say that it has 5. It falls a couple of times from a building, but it's still, and of course, I don't need to say evil because by default is true. And we can create another cat. Cat2 equal new cat. Oh, sorry. Cat2. We're gonna call this one, I don't know, any names? ABC. This is an adult cat, so it will say, well, this one is super old, so it's still have a couple of lives. Somehow this one it was raised in a nice environment. So this one is not evil. And then we can create also a dog, const dog. We don't need to create multiple dogs. We only have one dog. And this will be called Puppy. Oh, it's a smart. Now he has a DS. Puppy. Yeah, this is the most creative name. And small. It's a puppy. Because it's a puppy, he is super slow and clumsy. So we're gonna say just one. And let's do console log of everything. Console log. Welcome to our pet shop. We have a cat1 dot name. We also have a dog that makes this sound. And there you go. Let's reload the page. And we have whiskers that we can say there is a cat, and we can actually add a variable called type. So to say that whisker is a cat, and we also have a small dog that bark. So yeah, this is a small example. Any questions for now? Like Java, yes. Yeah, go ahead.
Yeah, I have just a general question. Do you know if in Sweden, many companies that look for front-end developers require TypeScript?
Good question. Actually, it's a really nice question. Right now, if you search in LinkedIn from front-end development positions, most of the basically, let's do that. Let's share the screen right now, and let's literally do that in LinkedIn. So let's open LinkedIn, and let's find front-end development jobs. Let's say, I think it's jobs here. Jobs and front-end developer. Front-end developer. And let's say Stockholm, Sweden. Okay, Sweden. Let's see, blah, 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 blah. Basically, it's always JavaScript or TypeScript. It's usually React always, like 90, almost 80%, at least 80% of the requirements between frameworks is React, then Angular, then Vue, and almost nobody has Svelte, the fourth major framework. Regardless, TypeScript or pure JavaScript, I think that the balance is 70% are okay with pure JavaScript. 30% are starting to request TypeScript, and this is the important part. I really believe that the pace is increasing. So, for example, next year it's not going to be 32% or 33% or 35%. It's probably be 40%, and in 2 years or 3 years at most, more than half of 50% of the jobs will be TypeScript. Because as you can see, for building large scale applications, it's super necessary to have this protection from the compiler. So that's why, as I told you, right now, TypeScript is an optional lecture. In 2 years, I probably, if I stay here, I probably will still be here. I don't know, maybe. In any case, so a lot of things can happen in 2 years. In any case, regardless of who is here, the front-end developer module will probably be 100% TypeScript. Yeah, maybe just one day for JavaScript, and then as soon as okay, JavaScript is a language for the web, blah 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 blah. This is a dump, and boom, lecture number 2, TypeScript from now on. Yes. So my recommendation: do you want to work as a front-end developer? You really consider yourself a front-end developer? Yes, invest in learning TypeScript.
So it will be only TypeScript, no React in that case?
No. In that case, let me go back to this diagram. And okay, don't worry. That's a good question because I haven't introduced React yet. So to answer that question, I need to explain what is React.
Okay.
Yeah, don't worry. No, but I love this kind of question. This is why I love these optional lectures more than the mandatory ones, because we can spend all the time making these questions. We don't have a time constraint because there is no homework for the optionals. Let's go with the root. What is React? First of all, so we can understand why it's important to combine it either with JavaScript or TypeScript. React is a library that is a JavaScript library, period. And why do we use React? We use React to make a high performance. We have 3 benefits. Number 1, you probably already, if you are working in your small your Cupcake website, many students are already started to make the question, hey, how come I can automatize the process of the header and the footer that should be the same in every single page? So front-end frameworks in JavaScript allows to do that quite easily. React uses a concept called components, and don't worry about that. You will learn what is components next week. I actually wrote a nice article about that. Another benefit is performance. Remember that example that I did about the DOM yesterday, when it was, I literally sound like a stupid person saying, oh, there is a file here? No, then I will go here. There is a file here? No, then go here. This is super slow in real life with pure JavaScript. React is smart, and they have an optimization to avoid this stupid path navigation and just make the changes in a snap. Another benefit from React. And another benefit from the React is that the one that we saw today, that we have information that was running out of sync. The titles, remember, array of titles. Hey, I actually have this graphic here. We remember that at one point during our application, we have a moment where our code base was out of sync. We were adding tasks and adding titles, but we were only removing tags instead of titles. So React has a protection for that one called state. So 3 benefits of using React. So React is a JavaScript library that allows us to do high performance web applications using JavaScript. But you can combine React with pure JavaScript or with pure JavaScript or with TypeScript on top. So in 2 years, the SDA will teach TypeScript instead of JavaScript. And when we reach to the 2nd week of React, it will not be React with JavaScript. It will be React plus TypeScript. And the website of the SDA will also reflect the changes and will be refactored or rebuilt or improved to modify our elements from React JavaScript to React TypeScript. But don't worry about this explanation, because starting in the weekend, you will start learning from React. And don't worry, the content for the next week is amazing. So everything will be makes much more sense starting next week, I promise.
Eduardo, I have a question.
Yeah.
Last example, which we have seen like in main.ts. Why are we importing cat.js and JS in main.ts?
Yeah, wonderful question. And the answer is simple. Be honest, I was reviewing the IP project today in the afternoon from certain students. So I didn't have time to set up to practice the TAJS config, this file. Let me share the screen. I'm sharing the screen. Yeah. This file is the one that tells the TypeScript compiler, literally the name of this file is TypeScript configuration. And this file allows me to set up the compiler. It allows me to tell which are where's the entry point, where is my files exported. And around, but because as when I show you, let me just write TAJS, let me copy this file. 1 second. I will create a new configuration file from scratch. I will delete this one just for one moment. Let me copy and let me make a backup. Let me make a backup because otherwise we're gonna break the project. Copy, paste. Yeah, and let me delete this file. And let me create a new TSC in it. So this is part to create a new configuration file. It creates a configuration file. Yeah, it creates a configuration file. The problem with the configuration file is that it has a lot of options and you need to read each one to see the correct option to actually activate the import TS files here.
Actually, sorry. Actually, we are not importing TS files. Why are we importing JS files here?
Yeah, this is the thing that I am trying to imply because I didn't have time to set up this file correctly. Okay. I need to modify something here to do exactly that because I didn't have time to do it because let me be honest, I was making the IP reviewing the IP project. I didn't have time to create this file as it's supposed to be done. So to avoid canceling the rescheduling the lecture, I just I do have a config file in the SDA platform, so I copied that one. But the problem with that one is that, as I told you, that uses React with pure JavaScript, so that configuration is a little bit different from the one the project that we are doing right now. So that's why we have this small defect that I importing JS files. It's a legacy because I copy a file that I was not instead of creating the file from scratch. So yeah, that's why. It's a mea culpa. But yes, you can set it up to make it work correctly. In fact, if I show you the SDA platform, I can show you that in the SDA platform, no, I don't have any multiple dependencies in that file. But we can do that in a normal configuration. You can do that without any issues. It's just because I didn't set it up properly today.
Thank you.
Yeah, don't worry. Any other questions? If not, then I think that we're gonna end for today. I think that they will be all for today. I will upload the video, of course. And again, this TypeScript can be as complex as Java. So that means that to teach actually all the features of TypeScript, we'll need 3 weeks, just like Programming Foundations. So that's why I moved it as an optional lecture. Instead of trying to pretend I was about to teach every single feature of TypeScript in one single sitting, my intention is to sell you the benefits of TypeScript and say, you know what? Okay, it sounds that it's actually quite useful. I will, after the SDA, I will decide to invest time as I want to be a front-end developer to learn about this technology, about TypeScript, because I can see the potential. So that was my goal in the TypeScript lecture, because if I want to actually teach everything, we need like 3 weeks or at least 6 hours in a row, and that's super heavy. So this lecture, instead of trying to pretend to teach everything, my main goal was to sell you the idea that there is benefits, and I show you a real case with the SDA platform that where we actually have errors, and we have the error of the creating an account is not a joke. That was a real case that happened all the time in the SDA 7, because the front end was pure React and there was no validation of the code. But because I knew that that bug was super difficult to find when the students were having problems creating accounts, so that's why we use TypeScript. As I told you, when I was allowed to create the platform from scratch, I can use any technology that I wanted. And I say, okay, I will not do it in Vue, even if I love Vue, because I want to use React to teach. But on the other hand, I really need the security of TypeScript. So that's why I just split the project into half. One part with React and JavaScript, like the one that you're gonna see next week. And the part that is super delicate, super dangerous, that part unfortunately needs to be on TypeScript pure because it's too dangerous to put it in JavaScript pure. So that's why. So yeah, I hope that you have enjoyed it. I will pass the files, but they are super basic. To be honest, it's better that you just watch the video and practice on your own. So yes, I prefer to upload just a video. And see you tomorrow. Tomorrow will just be a small fetch exercise, calling data from the data server. We are not going to post nothing because we are not going to send files to the server because Cabana is going to teach that in the next module, backends technologies. And then we're going to do a small introduction for clarify what is React and what is so important. So see ya.
Thank you.
Yeah, bye.
Bye.